In this example, we're going to evaluate integral ln of square root of x dx. First of all, let me remind you that there is no basic form of the integral of ln of x or ln of u or actually any logarithmic function. If you look at the table of integrals, you're not going to find one there, because to integrate ln, natural logarithm or any kind of logarithm, well, we have to use integration by parts method. And that's what we'll try here. Let's write down the integration by parts formula so that we can be reminded how to apply it. So integral of u dv equals u v minus integral v du. So those two integrals on both sides of the formula should look different, right? If it's u dv on this side, then it's v du on the other side. That's how I remember this formula. Okay, integration by parts. Integration by parts, well, the name of this method comes from the idea that we have to separate our original integral into two parts, u and dv. And we usually start by describing that kind of substitution. And a lot of times when we look at the integral itself, we can find two functions there. We can find a product of two functions. Well, one of them we call u, and the other one, along with dx, we rename and call that dv, right? But in this case, I can only see one function, ln of square root of x. By the way, don't get tricked over here, because that's one expression, right? ln by itself has no meaning. So it's natural logarithm or log with base e of square root of x. So that's one expression, right? I can't really separate them. Now, so where would we find the second part? Well, I can always rewrite anything as the product of that times 1, right? And that's what I'll do here. I can rewrite this as integral of 1 times ln of square root of x dx. And now by doing that, well, I can see those two parts. One of them will be ln of square root of x, another one is 1. And then I'll use dx with either one of those. Let's just think what's going to be u and what's going to be dv. Now here we have to remember that once we assign u and dv, we'll have to find du after that, right, by taking derivative in the first place. And here, once we assign dv, we'll need to find v itself through integration. Now, what is what in this example? Well, once again, if I have to find v by integrating the right-hand side over here, well, I shouldn't be assigning ln of square root of x here, right? We just talked about how we cannot find basic antiderivative of a logarithmic function in this case. So I'm not going to be assigning ln of square root of x here. It means that I have no choice but put it over here, ln of square root of x. Well, it means that dv, I'll make a note here, so that is u. Well, it means that dv will be 1 dx, that is dv, 1 dx. Well, integrating that, I have no problem, right? What is antiderivative of 1? It's simply x. So that's how we obtain v. And then on this side, if u is ln of square root of x, what is du? So this way we need to find derivative, differentiate this way, and then integrate here. Now, how do we find derivative of ln of square root of x? Well, we can see that it's a composition of two functions, right? So we have to apply a chain rule. Let's try it. I'll make a bit more space for me to write du. Well, chain rule. So first we have to find derivative of the outer function, which is ln. So derivative of that is 1 over square root of x. And then I have to multiply by the derivative of the inner function. So inner function is square root of x, which is same as x to the power 1/2, right? Square root of x is the same as x to the power 1/2. So derivative of that is I have to bring its power to the front, 1/2, and multiplied by x to the power that's 1 less than the original one, so it's 1/2 minus 1, which is negative 1/2. Well, I'll simplify that, so it's 1 over square root of x. I guess I should have put it in front, but okay, for now it's here, 1/2. 1/2 times a negative power I can rewrite as the positive power by taking the reciprocal, so it's 1 over x to the power 1/2, and x to the power 1/2 I will rewrite as square root of x, so it's 1 over square root of x times 1/2 times 1 over square root of x, and finally I can multiply everything out, right? 1 in the numerator, 2 I will put in front, and then square root of x times square root of x is just x. 1 over 2x. 1 over 2x. So that's, oh, and I guess I should put dx, right? Remember, that was our way to find for finding differential du. So du is 1 over 2x, and of course dx next to it. Okay, so now we have all the pieces we need for following the integration by parts formula. Let's see, I'll continue here. Now we have the left hand side right here, and then let's follow the right hand side. U times v. Function u is ln of square root of x. V is over here, times x. I'm going to put it a little bit further away so that I'm not confusing myself and think that it's all inside ln. No, that times x is outside of the ln, so I will rewrite it in the next step and I will put it right in front so I can avoid that confusion. Minus integral. Now here we have v, which is x, and then times du. Well, du is over here, 1 over 2x dx. 1 over 2x dx. A few things to simplify before we can think about the integral, the remaining integral. X, I'll put in the front, so x times ln of square root of x. That's this part. By the way, just to remind us, that's how we followed the formula. Ln of x, that was ln of square root of x, that was u, that was v. Now here x is v, and that's du. Okay, so x ln of square root of x minus, and here we can put 1/2 in the front, 1/2 square root, and then x times 1 over x. Well, that's just 1, right? X's we can divide out, so it's just going to be 1 dx. Okay, and then now as we look at the remaining integral, we can see that it's very simple, and we can easily evaluate that. X ln of square root of x minus 1/2, derivative of 1 is just x. And then of course plus c, plus the constant. Actually nothing else to simplify here, right? So that looks like a good thing to box, because that is going to be the final answer. That's going to be the result of evaluating our integral here. So just to summarize what we've looked at. So the main idea or the main point of this example is to remind you that if you have to integrate logarithm, standalone logarithm, there is no basic rule for that. You have to apply integration by parts where you rewrite your logarithm as 1 times ln of whatever you have there, and that will always be u as you try to follow the formula, right? Since we're not able to integrate, so it has to be u over here, and we can differentiate. That's how we can approach this. So that's this example.